All right, good afternoon, everybody. We will be starting here in just a minute. I see we've got 15 people already here with us. So again, thank you for joining. My name is David Klotz. I am the Director of Federal Accounts with Enola Technologies. So we will begin here in just a minute. We'll go ahead and get started right on the hour here, and I'm sure there's going to be some more people joining, but we're excited to cover this material with you today. So again, we appreciate everyone taking the time. After this is all over, we will send out a recording of it. So if you have to leave halfway through or anything, no worries. We'll make sure everyone gets a copy so you can go back and review this material if you need it. All right. So again, for those of you just joining, my name is David Klotz. I'm the Director of Federal Accounts with Enola Technologies. I am excited to present to you today SysML V2, the new rules of the model-based road. And we will go ahead and get started. So Tim, if you can go ahead and hit the next slide. So before we jump into the fun part of the presentation today, wanted just to do a quick overview for those of you who may not be too familiar with Enola Technologies. We are a leading training and coaching and consulting firm, and we are dedicated to the rapid evolution of our clients within the digital world. And our services are directed towards digital engineering, transformation, model-based systems engineering, enterprise architecture, software, database architecture, ontologies, and collaboration server management. So tools like Teamwork Cloud to be your model-based repository. We have been in the business of model-based systems engineering and digital engineering consulting since we were founded in 2021. But most of in fact, all of our founders are a decade plus seasoned veterans of model-based systems engineering. All right, Tim, next one. And our mission here at Enola Technologies is to train, coach, and mentor your staff to be independently successful as quickly as possible. So that is our goal, is by sharing the knowledge that our team has accrued over decades of experience to be able to help accelerate your programs into being able to deliver on time and on budget for whatever your mission parameters are. And then finally, what you're going to be seeing here is some of the information that Tim, our Chief Operating Officer, is going to be presenting today is actually going to come from our SysML V2 training. So this is something that we are releasing and really has now released as of this year. So we're excited to be able to present some of the information in this overview today. But Enola offers a variety of trainings. You can see we have an open enrollment calendar. So if you're an individual within a company or an organization and you just want to shore up your skills or maybe get your foundations under you, we offer a variety of classes. Most of our tool work is within the Cameo or CATIA Magic set because that's the background that we came from. Most of our founders, myself included, actually worked at No Magic before they were acquired by Dassault. But we are tool agnostic. So if you are looking to learn SysML in another tool or UPM or UAF, let us know. We have expertise in a variety of tools like ANSYS, Innoslate, a bunch of others that aren't coming to mind right now. But we've used a variety of different tools, Enterprise Architect from Sparks, etc. So if anybody is interested, please contact us at sales@enolatechnologies.com, and we look forward to being able to set you up with the training that you need. Or if you have a larger group, we can train groups between 12 and 15 at a time, either on site or virtually. So with all that, now we will get into the fun presentation that you all are here for.
All right, thank you, David.
Yeah. Oh, and let me give you go to the next slide real quick, and then I'll just give you a quick introduction. So before I turn it over officially, Tim Anderson is our Chief Operations Officer. He is also one of our founders at Enola Technologies. Tim has over 15 years of model-based systems expertise and experience. And today, what he will be covering is an overview, a quick overview of MBSE for those of you that are still getting your arms around model-based systems engineering as a practice. He'll go over the basics of the systems modeling language, sort of where it was in V1, and then he'll move on to the basics of V2, discuss some sample views, and finally explain how to prepare for the transition for those of you who are excited about moving to V2 and the ease of use that will come with the textual notation and the integration and AI possibilities. He's going to be talking a little bit about that for those of you that are already well versed in V1. So high level, some great tips and pointers. So without further ado, our COO, Tim Anderson.
Thank you, David. As David mentioned, we're going to be going over the basics of SysML here, SysML V2, that is, of course. We're going to have some introductions here with the MBSE and SysML in general, but a lot of this is geared towards that translation from SysML V1 into V2. So you'll see a lot of this is going to be comparative, where we're looking at what was in V1 and what is in V2. The stuff that's in here, if you're new to SysML and MBSE altogether, again, welcome. We will be covering some basics of that as well. But the audience is really gearing towards what does it look like now in this new world of V2. So again, want to welcome everyone, and let's get started. So we'll start with an MBSE overview. I'm assuming a lot of people that are here have an understanding of what MBSE is, but for those that may not, MBSE is Model-Based Systems Engineering. It is the formalized application of modeling to support, you can see these red words here, system requirements, design, analysis, verification, and validation activities. This is where SysML was originally brought in, SysML V1, and they retained this for V2. So these concepts of requirements, design, analysis, verification, and validation are things that we're going to find in this language in V2. In fact, we're going to hopefully streamline that idea. Some of these things that we had in SysML V1 were a little cumbersome to work with. And with V2, we're looking to make this a lot more streamlined, a lot simpler, and a lot easier to adopt. MBSE is, again, a model-based approach as opposed to a document-based approach. Document-based approaches would be those where we had, several different stakeholders. Each would have their own, set of key artifacts, PDFs, Excel files, Word files, you name it, and they were all disparate. MBSE focuses on bringing all of that content into a single repository, a model repository, where all the key concepts across all those different documents can be referenced in a single place. Again, nothing new here. This is something that SysML V1 tackled, but V2, of course, will tackle it as well. Another benefit that we'll see in V2 is that it focuses on interoperability. That's a key tenet of the language. And so if you are working with other tools, with other technologies, or if you are needing to share information between vendors, the language of V2 was built specifically to help furnish that moving forward. And so we will hopefully see a lot more interoperability between these different tools, and you're not locked into vendors for good or for bad, however that may be. With everything being in one location, one repository, we can do things like querying, we can do traceability, we can do simulation. In fact, here, get a little ahead of myself here. My next slide walks through all of those different advantages of MBSE. I'm not going to list off all the things that we have in this slide here, but you can see there's a lot of good stuff we get with a model-based approach. Again, regardless of the version of SysML, you're getting all of this good all these good features, right, for being in a model-based environment. So integrations, configuration management, simulation, that's for like verification and validation activities. General would include things like traceability or reuse. All of that stuff comes along with MBSE. All right, with that out of the way, let's get into the fun stuff. So systems modeling language. So that's SysML. Systems modeling language is a standard that's been around since 2007. It is your vocabulary for model-based systems engineering. That means it's going to provide your elements, your nodes, your relationships or edges, and then the views that you're going to need to capture whatever it is you're trying to capture within your system specification. Ideally, those 5 key things that we saw a few slides back. So requirements, design, verification, validation, all those things need to be captured somewhere in that vocabulary along with all the supporting staff as well. So that was V1. V1 was back in 2007. We had 7 minor releases after that, so we got up to 1.7. And back in 2017, they recognized that, hey, we're wanting to do an overhaul of the language and we want to streamline what we have. And that was where V2 came into play. There's an RFP to build a SysML V2 back in 2017. It took a long time, it took a very long time, but 8 years later, it was officially released last September. And so it is out there, official version 2.0. They're already working on version 2.1. They're already looking to improve upon it. But as of now, you have access to SysML V2 tools like Cameo's Systems Modeler or Cameo System Modeler or Katia Magic, the MSOSA product. Now have deployed solutions for these. These are production ready deployments. So 2026X for those tools are available, and you can start playing around in SysML V2. So what are some of the key differences between these two versions of SysML? And then they are pretty big differences. So it is a pretty major leap to get over here to V2. Ideally, though, if you understand V1, it's not the biggest jump to V2. Honestly, a lot of it would be unlearning some of the stuff that you had in V1 that no longer applies to V2. But it's not the concepts match between them. So we'll start in V1. V1 was built on top of UML, which is the Unified Modeling Language. That is a software engineering specification. So it's all about building software. It's got a lot about, it's got deployment views where we can show where software is going to get deployed onto different servers, artifacts in memory, things like that. None of that really applied to the system engineering side. We're looking at systems and their subsystems and their behaviors. And so when SysML came around to do systems engineering, they borrowed from UML because that was a core language that a lot of other languages were backed by as well. They stripped out all the unnecessary stuff from UML, which was a decent chunk of the language was unnecessary for SysML. And then they created some new things like requirements or parametrics for doing calculations. Those didn't exist in UML. So they built it as a profile, adding to that overall language. Now, because it was backed by UML, there were many quirks, we'll put it nicely, that had to be overcome, right? In order, and speaking from experience, I've trained hundreds, maybe even thousands of people at this point in SysML V1. And a lot of those things are confusing, especially for new users. Why do we need to do that? Because you have to, which we're forced into doing it that way. And that's never a good answer when you're trying to learn this. It's just yep, you got to do it because you got to do it. And so that was a huge thing that they tried to overcome with V2, is that those quirks of UML, they were really wanting to get away from that. And so they did. And so that was a big thing in version 2. And this is why it's such a big leap over to V2, is that the entire skeleton of what was SysML V1 has been ripped out of that language and replaced with a whole new skeleton. That new skeleton is kernel. You can see it here in the top right corner. So kernel is the kernel modeling language developed alongside with SysML V2. It's for modeling languages. It's not quite the same as UML. You might have heard of MOF, the Meta Object Framework. Similar to that, where it is a language that describes languages. And it's pretty simple. We're talking like 20-ish different constructs in the language that are the core of that language. And then SysML V2 is built from that and expanded upon many elements. So this removes UML and this allows it to be its own thing. So it is something that is driven and shaped by these system engineering needs. It's not a software engineering application that is now being borrowed to do system engineering tasks. So it is much more streamlined in that sense. And they made sure when they did this to have a corresponding connection from what was in V1. So there were a lot of concepts that were very, very useful in V1. You got use cases, requirements, the ideas of blocks and parts and all that. they're all translated into V2. So you're not really losing anything. We're losing the stuff that was confusing, and we're losing the stuff that was unnecessarily cumbersome from V1, and we're picking up a lot of cool stuff here in V2. So that's what you want to think about when we're moving over here to V2. But this is the reason it's such a big thing. If you've heard all the buzz, it's because the backbone of the language has now been replaced. So, what do we get with all that? Well, there's a whole bunch of key features you get with SysML V2, and they're still being built. Like these are some of the tenets that they were doing when they were building V2. But what do we get from it? We'll see, right? As they continue to develop the language, hopefully this gives them the versatility to bring a lot more stuff into this language. So a big thing that they did was they simplified the meta model. We're not looking at 200 or 300 different types of elements. We've shrunk it down to a much more feasible amount here in V2. So it's looking to make it a lot easier to adopt for new people, and a lot easier to use for those that are used to it, your existing practitioners. It's maintaining consistency across the language. You'd have a lot of I don't want to keep using the word quirk, but UML had different terms for things like definition elements and usage elements. And we would teach, hey, a block is a definition element and a part property is a usage element. But the idea of definition and usage weren't baked into that language. It was just a term we would use to describe it. Here we have definition and usage. Not only do we have it for things like blocks and part properties, we have it for practically everything in the language. Nearly anything can be a template or a definition, and then we could have a usage of that where it's, typed by that definition element. And so they contain that across the board, and that simplifies a lot of the terms and makes it a lot easier to work with. Knowing that, is that definition or usage? Well, you just look to see if the keyword DEF is next to it. If it says def, it's definition. If it doesn't, it's a usage. The name in front is the exact same, whether it's definition or not. So that's the cool thing in this language, and we'll talk a little bit more about definition and usage a few slides later. It retains our ability to extend the language. One of the reasons UML was so popular is because it had the ability to be extended. So you could do domain-specific languages. So that was profiles, your stereotypes, your tag values. We don't have profiles, we don't have stereotypes, we don't have tag values here in V2, but we have other means of creating our extensions through ideas like metadata, which are types of annotations in this language. So you still have that ability, but, and we'll talk about this a little bit later as well, that's going to be part of the migration that we have to do. When we're moving from V1 to V2, this is a key part where, yeah, you don't really have profiles and stereotypes, and so what do those get translated into? There's not a clean thing that it translates to. You'll have to, for the most part, manually make those edits. Or automate them, on your own if you have some customized automation. But that's another key thing here, is that we still have the ability to extend for things that weren't necessarily captured in the core specification. Interoperability, I mentioned that a few times already, but there is a textual notation attached to V2. We will see a few slides on the text notation, see what it looks like and kind of what we get from it, which is really, really nice because we can then dump that text file out. And the idea is that we can share that text file across different tools. And if they're conforming to the standard, you should be able to pick that information back up on the other side. There are obviously going to be caveats to that exchange. We'll see how realistic that exchange concept is across the different tools, but this is meant to be an improvement on the previous XMI, which was honestly practically useless. You had some third-party softwares that could help make XMI a little bit more of an exchange language, but most of the tools implemented those in their own special way. And presumably they'll do the same thing with this, but it should be a lot more difficult to make them not interoperable. Another cool thing you get with V2 is the flexibility of views. We're going to talk about this again as well a little bit later, but we don't have prescribed views in the same way we did in V1. We had requirements diagrams and block definition diagrams and package diagrams, and a lot of the training out there, ours included, were built based on the diagram types and how do we learn what goes into this diagram. With this being more streamlined, there's not a need for that. So we will learn how to do different views, but those views are flexible. They're there to display what we need to display, and they're well, for one, they're a lot less. We have a lot less of them, and it also opens up the door for some new ones as well. So we're not going to focus on where's my requirements diagram. It's going to be here are all my requirements of my model. Whether or not I choose to view them in this implementation, it's called a general view, is up to me, right? And whether or not I want to show them, or I could show them in a grid view. That's our tabular approach. So we're going to talk about that a little bit later, but that's a really cool thing of V2 is that we're less focused on the kinds of diagrams, and then we just have data that we can view in a few different ways. And with our libraries, the possibilities of different views and how we render them actually is near limitless. We can show it in so many different ways. We also have the textual notation. I mentioned that as well. That lets you code effectively. That's really what it is. It's a model as coding. So if you wanted to, you could just type in text your model, save, and then it will translate that into the model for you. So you don't have any typos or syntax errors. Your tools are going to help catch those, of course, and they'll help you work with those. Or the other way around, you could build things graphically and then say, okay, let me see the textual notation. Um, there are so many good applications for this, one of which is the interoperability, but others, you can more discreetly change your model, right? If you're trying to, there's many times where I was working in V1 and I was trying to find the right spot to make a change. If you're in the text notation and you know what you're doing, you can find that spot in the text and make those changes pretty quickly. And then just revisualize your information. If you're doing something like AI, right? That's a hot topic now. AI can help build a bunch of this stuff out just like it's doing that with coding. You'll still want to do your due diligence and make sure that everything is you know correct, but it can help front load a lot of the work here and get you most of the way that you can, and then your SMEs can go and finish it up and clean it up. So a lot of cool possibilities with the textual notation, and probably the thing that has the most buzz, I would say, for V2. It also tried to ensure that we had a migration from V1 to V2 and that it wasn't super cumbersome. Again, they have the migrators and they have descriptors for tools to do these migrations. It's still not going to be great, just warning you now. If you have stuff in V1, it will be a process to move it to V2. You have to do some pre-massaging of the content. Then there are automated migrators, like Cameo has its own migrator plugin. And then there's often going to be post-processing as well, where you then rearrange things and get it to where it needs to be. And then once it's migrated, you're not really going to be switching back and forth. This is a one-time push. You don't want to really move back and forth. So don't expect this to be a clean connection between the two views. You are leaving V1 and moving to V2 when you're doing these migrations. You also get an API. So again, coming with the textual notation here is kind of think of these APIs as libraries. Same idea. Where you have a bunch of different functions and types and kinds that are standardized in the language itself, and they intend to continue to expand on those as we keep going forward. So just things that you have access to, which is really, really nice when you're doing your modeling. And then finally, it adds new concepts, right? Some of the things that we didn't have in V1 that they just never got around to implementing. Now we have access to it in V2. Things like temporal concerns. You had that in like UAF and a few other things, but didn't really have that in SysML without having to create it yourself. And then spatial concerns like geometry. We have shapes. We have 3D and 4D positioning. You can caption that kind of stuff here with these kinds of libraries. And again, we'll see that in a couple slides, some of the content that we have in these libraries. So a lot of cool things that you're getting with V2. And this, again, just the first iteration of V2. They're going to continue to expand on this as they continue to see what works and what doesn't work. All right, we're not going to spend a lot of time on this picture here, but this is just a background of the architecture of the language itself. As I mentioned before, kernel in the bottom left corner here, this is your meta model for the meta model, effectively. So it's the underlying backbone. This was what used to be UML. And then SysML, or your SysML 2, is up here. It's using kernel. The libraries here are what you're actually going to access in the projects. So when you're doing your modeling and your tools, you're accessing these libraries, and these are the meta models for those libraries. So the types of elements that you have access to at the kernel level versus at the SysML level. And then these domain libraries, again, are some of those APIs and things that are provided for you, as well as additional libraries that the tool vendors may create or that your individual organizations may create and hold on to. Some of the libraries that are in that list, and again, these are standard libraries that are in the specification. You've got a metadata domain library for capturing metadata annotations. Again, think of like profiles. You got analysis domain for doing things like trade studies. We got cause and effects for cause and effect, requirement derivation, geometry for basic shapes and locations, and then quantities and units holds on to all those ISO 80,000 types. So just like we had that back in V1, that was a standard profile in Cameo, you have that now built into the language. And these are things that are referenceable, right, in either that textual notation or just in your graphical notation as like types of things that you can select. So a lot of good stuff here. And again, completely extensible, not just from you, but the language itself will continue to expand on these as it continues to grow. All right, so that's our overview of SysML. And kind of the transformation from, and how it relates to V1. Now we're going to look at some of the basics of the language itself and see some of the translations. What was it called in V1? Yeah, what's it now called in V2? So the big thing here is definition and usage. I've kind of already alluded to this a little bit earlier, but this is how we reuse information in SysML. It was a major thing in SysML V1 because, again, it's a major concept of MBSE. You define some template or blueprint, whatever you want to call it, of a kind of object, and then you can effectively print that over and over again. I have an engine in my vehicle. Well, what is an engine? I can describe that as a template, and then I can say, okay, this vehicle has an engine. The crane over here has an engine. My motorcycle has an engine. The idea of an engine can apply in many different applications. And so that's what we had in V1. And not just for structure, it was also for behavior. We could have a common activity like making coffee. I can make coffee in the morning. I can make it in the afternoon. It's the same process, but it's a reusable behavior that I can define once and you reuse it when I need to. In V2, we use the term def, you see it right here, DEF, to mark that something is a definition element, and then in the absence of the word def, it's assumed to be a usage. So those are your two options here. It either is a definition element using the keyword of def, or it's just usage if it's just the name. So instead of blocks and part properties, we'll have part, that's our name of our usage, and then part def is kind of like a block. It's the definition of a part property. And that's the kind of streamlining that I was talking about, is that we've made this a lot easier to reference these terms, and you're not having to think, okay, block and part properties. What type's a part property? Oh, obviously it's a block. Well, in SysML V2, what type's a part? A part def. What type's an action? An action def. It's always the same. It's just def is the term that we'll use for the definition kind of object, which is really, really nice. So again, definition is our reusable concept. Usage is that usage of that template in some context. So it's created somewhere in there. And like I said, this is consistently used throughout the architecture. All right, here is just a slide of some of the transformations, some of the translations that we have access to here in V2. On the left was the old V1 term. On the right is the V2 term. This is nowhere near an exhaustive list. It's not meant to be, but that's what you're looking at here. We've got block is a part def, part property is a part. You see it's consistently an interface block is the port def, the proxy port is the port. If you want to think of it the other way, honestly, it's probably easier to think about the kind of object that we're looking at. Like an attribute is a value property in V2. The attribute definition is what types that. Well, that'd be the value type from V1. Actions are still actions, but the definition of an action, that was an old activity. And so you can see on here, again, for a lot of these, that's all it looks like, is that you have the usage, which is the thing we're mostly working with, and then the definition is just the template of that kind of object that can be reused. We do have some cool things in this language. We have a requirement definition now. So you could define a template of a requirement and then usages. And these can be composed of lower level requirements. They can have constraints attached to them. There's a lot of cool things that we get here in this language. We have connections and connection definitions. A couple of things that are different. We have generalization is now a specialization. It kind of goes the other way around. And there's a few flavors of that for how they specialize. Composition is now a feature membership. So if a part has a part, composition used to just say, yep, that's an internal part. Now it's just called a feature membership, whether it's composition or aggregation. And then for the diagrams, we have view definitions and views. So view is the term we'll use instead of diagram, because again, diagram's a little bit more specific, looking at like something graphical. We're using view for pretty much everything. View is just the general term for something we can see. View definition is the kind of view that we can have, and then a view is the actual diagram of what we used to call a diagram. And what are those diagrams? What do we have access to here in V2? Well, in V2, we have different views that are available to us. Again, these are like the diagrams, but they are, as is the language, streamlined. We have general view. That's going to be your go-to for just displaying content. It's mostly for members. So this would be something like a member would be a composed part, containment for a package, composition for a requirement. If we want to see the inner workings of something, that would be a general view, or just anything really that we want to see the hierarchy of something. So our general view is just kind of that all-around display view that we're going to see a lot of. An interconnection view is an internal view. Think of this as like an IBD, but it shows the features within an object and how they relate to each other, how they connect. So the obvious connection is an IBD from SysML V1. That would include parametric diagrams, because that was also a connection point. And then we also have other kinds of interconnection views, like the action flow view. It is called out as its own type of view, but it is a subclass of the interconnection view. It's a type of that, because we're looking into an action member or action definition, which is an activity. We're looking inside of it and seeing how those actions relate to each other. So same idea, just for an activity. That's the kind of stuff we're talking about when we're saying that this language is streamlined. The action flow view would be like your activity diagram. It works the exact same way as it used to. You have actions to represent the steps within your process. You've got swim lanes still. You have flows. We call them successions now instead of flows. You've got objects that can be passed, input, output pins, all that fun stuff. Your control nodes are all the same. Again, slightly different names, but the ideas are still there. So if you've seen an action flow view in V2, you should be able to read it if you're familiar with your activity diagrams in V1. Same idea with state transition view. It's just your state machines. Sequence view, just to round out your three behaviors, it's a sequence diagram. The geometry view, this is a new one. Geometry view is going to be used to show the spatial location of your objects, and so you can kind of use this to really get a feel for the spatial location of your architecture. This could be like CAD drawings and things like that. That's what kind of the idea with the geometry view. You've got a grid view. This is mostly just going to be a table, but it's anytime you're showing rows of data. But this is going to be your table generally. And then you have a browser view. Browser view is like the containment tree. So it's a way of showing a hierarchy in a tree-like structure that you can expand into. to look into the contents. And so the browse view is pretty much your containment tree. So these are the defined views that we have in SysML, and then we can build customized views based off of these. Um, the view defines the structure, and then we can render that view in a number of different ways. That's getting a little bit more into the weeds, but that allows us to have more flexibility into how we can see the information here in SysML. Just like we had the mapping for the elements, here's a quick little mapping for the diagrams. Half of them are general views, so packages, requirements, use cases, block definition diagrams. If you think about it, you were just putting a bunch of elements into a free-floating diagram. The different diagram just told you what to put in it. That's just unnecessary. So we have general views across the board. Internal blocks and parametrics are interconnection views, and then your three behaviors, of course, are the three behavior views that we now have. And then the other views that we mentioned are just bonus. They're new views that we have access to. All right, the textual notation. So the textual notation is, again, a big add into this language, and it is a textual view of your architecture of your model. And it looks like this. You can see it on the right-hand side here. So this is coming from the simple vehicle model. We're going to see a few samples of that. Again, this is a standard sample that we have in 2026X Cameo systems modeler, so you have access to this if you want to go play around with it yourself. If you have that product, you can go see this same example. Here we've got our simple vehicle model is our containing package. That's your root of the entire architecture. And then it's kind of skipping ahead here because, again, this is just a nice little trick of the text notation is they got a nice little set of quality of life features. So package definitions and then package attribute definitions, it kind of collapses those so we don't need to see the whatever else is stuck in there. We can just kind of see that, nesting, and we'll see this are all the content of this attribute definitions of that simple vehicle model. Yes, there is a learning curve to this. You do have to learn this, but as you're learning how to do the graphical notation, you should be learning how to do the textual notation at the same time. And as David alluded to with our class, we do exactly that. We teach you both notations together. So you can switch between the two or just stick with the one that you prefer. The idea here is flexibility. If you don't care to do text-based modeling, don't do text-based modeling. Focus on the graphical, and vice versa. So we have a bunch of imports, public, private, protected are all still available visibilities. If you're familiar with those from UML, they were brought into SysML. Imports different libraries. These are some of those libraries. We were just talking about those domain libraries, like the SI units, the quantities, scalar values. These are all coming from those standard libraries, the domain libraries. We can alias things, which is a cool little feature where we can say that torque value in this package is also known as torque. And so we can just refer to it as torque, even though the real name is torque value. We can define enumerations. Again, this is the definition of an enumeration, enum, def, colors, and then we just say black, gray, red. Those are your three different types. 60, 80, 100 millimeters for your diameters. This little feature here is just letting us know that diameter choices here is a kind of length value. We have a couple other enumerations, and then just a bunch of properties specified down here in these attributes. So these are the kinds of things that we can track here in the textual notation, and that will translate into the architecture. And if we were to, generate a view based off this, we could see that content. In fact, with this next slide here, you can kind of see the two next to each other. So on the right-hand side, we've got a general view here where we show a logical architecture package. That's what we have up here. We've got doc. This side we can do documentation within the language. So you just say doc and then put your comment in there. We've got a vehicle part definition with engine and wheels. Again, should look pretty familiar here. We have colons to represent types. These are multiplicities. Attribute pressure, it's a value property of type SIPA, so it's a Pascal in the SI library. And we can see that's right over here. Here's our part def wheel with the value property pressure of type Pascal. See, it tracks that. And these connections here are all managed. You could either build it from the left and generate the right, or build it on the right and generate the left, but they will stay consistent. At least in Cameo, when you're trying to work with the text-based notation, it is something that is generated whenever you open the editor. So it is an option to say open the editor, and it will regenerate the text based on what's in your actual architecture. So this is not saved, if you will. This is not, you're not going to be, making changes in here and then trying to push them, or making changes and hoping that that they get updated on the other side. If you're in the text-based area and pushing, it will do so. But if the text editor is not open, then there is no existing text notation, if that makes sense. Instead, when we tell it to open, it will regenerate the text based on what's currently in your architecture. I don't know if they intend to keep it that way, but that's the way that it's currently built. Okay, so that is it for your V2 overview. Now we're just going to look at some samples to see kind of what this language looks like, and then we'll wrap up with our transition plans as a final section. So again, we're not going to go into really low-level detail here with these samples. Just kind of want to show off what this language looks like so you get an understanding of this new format. It should be very similar. Again, for most people, you should be able to roughly read this if you've done V1. Most of this should look familiar, and you should be able to intuit a lot of the information. For example, we have a requirement. It says so right here. This is a value specification. We're using composition. Again, we call this feature membership in this language, but it's composed of lower level requirements, which are composed of further lower level requirements. So we're drilling into these requirements. There's a lot more we can do with requirements in this language, which is really nice. We can assign subjects to them, so who is responsible, or what the requirement is about. In this case, it's the vehicle. We've got documentation for the text of the requirement. We've got attributes of the requirement, which is really nice because we can trace to those and use those attributes. And we can assume constraints as well. We can put actual equations that need to be satisfied
Hey,
live
Tim.
on here. Yes, sir.
Sorry to interject. Ben Sweet had a quick question, and while we're on this, I think it's a super easy answer for it, probably, hopefully.
Okay.
He was just asking for clarification on what some of the symbols being utilized are. So, like the dollar sign, greater than, less than,
Yep.
number sign,
That would be back over
as
here
you're
probably.
explaining that. Yep.
Yep. Yeah, so we'll real quick. So I did gloss over these just for the sake of time. I'm sorry. So these are the internal IDs. So if we want to refer to any of these objects in Cameo, this is how Cameo is keeping track of them. So these are the IDs for these objects. Um, the less than, greater than here, this is a short name for the logical architecture. So you can see it's up here. It's just a short name that you can attach to it. The greater than signs, these are shorthand. Won't get into too much detail here, but these are usually the generalization relationship. So this one right here is saying that front driver wheel is a kind of wheels. You can see the relationship right here. It's that same generalization. We call it specialization in this language. The double arrows is redefine. So we're redefining the pressure to be 36. Normally there'd be a name on the other side of this, but since we're keeping the name of pressure, we don't need to include it again on the left. Like I said, we could dive into a lot of this stuff. There's a lot of content here, but these are shorthand for a lot of those concepts. And so it might look a little intimidating, but it's just a couple different types of relationships. What's kind of cool though, if you look in the diagram, it might be hard to see, but if you look on the diagram, some of these generalizations have the dots next to them, which coincide with the dots that are over here. So like this is the push. We have the wheels as a kind of wheel here. This guy here, wheels is a kind of wheel. With the colon, it shows the colon on there. So that's our kind. That's our connection from a part to its type. It's part def. So
Perfect.
that's what we're seeing in here.
Yeah, well,
Yep.
thank you for that. And Ben, thank you for the question. Also, we will have some time at the end for all the Q&A that we've been getting. So again, please feel free either in the chat or the Q&A. But since that was so specific, I just wanted to interject before we had to go all the way back to it. So thanks for that question, Ben. And back to you, Tim. Sorry.
Excellent, thank you. Yeah, no worries. So like I said, we'll kind of go through the rest of these a little bit quicker. But again, for the samples here, we're seeing a breakdown of requirements. That's the big view that we're looking at here. Again, this isn't a requirements diagram. It's a general view. It's just a view of requirements. We can show what we want. We can display what we want in the compartments. We have the flexibility, just like you did in V1, but it's expressly more here in V2. Similarly, here's a use case and action flow kind of merged into one. Uh, there's no use case diagram. We just have a general view. So the general view could show our use case. In this case, it's this transport passenger element. And we can describe that use case with a flow, just like we could do so with an activity. Right? If you recall, a use case can be refined by an activity, usually stored within it. Here, there's no need for that. The use case just can be broken down into its action flow, and that's what we can see in the compartment within the use case. So not showing a whole lot here. It's just a start node with its forks and joins. The driver and passenger get in the vehicle. Then they provide power and drive the vehicle to destination. Then the driver gets out, the passenger gets out, and then we end. Things like decisions and merges and all that are valid here as well. Again, you can send data. We can satisfy requirements. All that fun stuff can still be done here in the action flow, even though this is kind of a simple example of that action flow. We also have structural decomposition. One of the cool things about SysML V2 is that you can show parts being composed of other parts. Notice there's no def next to the word part here, which means these aren't the block type elements. These are just the usages. They wanted to make sure that you could have usages be composed of other usages. And so we get that. So you don't have to build a giant block structure just to have structure. You can do it with your, what were part properties. Now we're just calling them parts. So this is a vehicle of type vehicle, and it's composed of engine, starter motor, transmission, drive shaft, but these are all usages. They can still be typed by something else elsewhere, but we can show the composition and connect them directly here without a need to create a giant block definition diagram describing that. And again, that's consistent in the language. Other things like activities and other things have that same capability. Here's an interconnection view showing kind of like an IBD where we have the internal parts. Remember, everything in here, these are views where we're looking into something, and so we can see the vehicle is the part, and this is the IBD within that part. We've got the different subparts, even multiple nested. We got connections, that's what we call these instead of connectors. We've got ports, we have flows, we got border ports on the vehicle itself. Everything you're used to having in SysML is found in here as well. It's just, again, a lot cleaner. State transition view, just another behavior view. Same idea. The state itself is something that can be decomposed into lower level states. You have transitions, you have behaviors that are being performed. Most of this should look familiar because, again, it's translated pretty cleanly. One of the really cool things in here, which you may not see at first glance, is this little caret sign in front of health states. The caret means the same as what it used to mean in V1, meaning that this was an inherited state that we then could redefine or use. So things that weren't available in V1, like inheriting behaviors here, are now available here in V2, which is really, really nice. And then we have analysis and verification cases. These are things we mentioned before, but these are new concepts here in V2. Analysis for things for building things like trade studies. Verification cases are for doing things like test cases. And so you can see some examples of how those are related to the relevant objects here on these two views. But the analysis just breaks down the subject, its objectives, attributes, and parameters. Your verification case shows the parts, that would be the structure that's doing the verification, the activity that's being performed to check it, as well as some metadata assigned to that verification. And then finally, snapshots, another thing that's relatively new here in V2. We have snapshot is what it sounds like. It's a snapshot in time. This is how we can look at things temporally. We have time slices. You can see the term here, time slice, which gives us a duration of time. And then a snapshot is literally where the start and end date times are the exact same. So it truly is a snapshot. In this case, they're saying time is at 0 seconds, at 1 second, and at 2 seconds. And they're kind of building out a structure based on that snapshot. These are individuals which if I kind of glossed over it in the previous slide, but that's an instance in this language. So individuals are instances. So here they have like an instance tree, if you will, where we're seeing the uh, relevant values, right, that we have at a given point in time. And so that's it for the, just again, some samples of looking at this language and some of the things that we have in SysML V2. We're a little bit low on time, so I want to finish up these last couple slides so I can open up the floor. So we're going to run through these last few slides a little bit quicker. We have transitioning to V2. So one of the big things that we want to make sure is clear is that V2, yes, it came out in September. Yes, it was in development for a long time, but it's still really new. Um, as far as Cameo, which is a very big player in the system engineering market, they only released their production version of SysML V2 back in November, late November. So this is all very new stuff. People have been building to it and they're familiar with it, but there is a lot still left to be built, and there's a lot of things that are still being ironed out. So just like, I don't know if anyone was around for V1 back in 2007 when it first came out. There were a lot of upgrades that they made over the years, a lot of good features that came out of it that have yet to be incorporated into V2. So a lot of groups may not be ready to move over to V2. This is something that maybe you want to do like a pilot program and check it out and see what you feel. But there's a lot of features that are core to Cameo that may not exist in this, or that you may have to relearn to do it a completely separate way here in V2. So those kinds of things you got to keep in mind as we're moving over to these other this other language. Things are going to be really, really nice, but it might take a little bit more time to get to the point where you are doing what you were doing in V1 and more. So it's still a work in progress in that sense. But a lot of good things in here that are existing, and there's still a lot we can do in here. It's definitely worth learning and starting to play around with it. That being
Um,
said, once you, yes,
oh,
you have a
sorry,
question.
I forgot one more, and then we have some great questions to get to.
Okay, so two more slides. Learn the language and the tool. So first thing you can do now is, pick up, V2 now while it's, hot. Start to learn what does this language offer, what can you do with it, and start to get a feel for how you can use it within your organization. Obviously train up if you want some power users or if you want to train the team to start doing it. Now is a great time and to start learning the tool, because hitting it at the ground level here would be a great start to really getting your organization using V2 to use all these cool, powerful tools that we have access to now. Your V1 models, if you're working on a big model, might be worth to keep it in V1 for a little bit longer, just because the migration ever can be a pain. So do some pilot projects to get familiar with that process and become more familiar with it. But you know, you may not want to migrate right away from V1 to V2. You might want to kind of play in both worlds for a little bit as you're trying to move on to V2. But if you have new projects, not a bad idea to start trying to use V2 for the new projects. And then when you are ready to migrate, again, it's a three-step process. You will have to pre-process your model to make sure that you get rid of a lot of those special customizations that you have built, and that you're prepared to rebuild them on the other side. The migrator will change that content over for you as much as it can, but you will have to do some post processes on the other side. Some of that can be automated, especially if you have customization with your automation, things that aren't just general. If you have a targeted automation like a macro or something, that could help wean you off of your V1 model. But there's still a lot that you'll have to support on the V2 side. All right, that is what I have. David, would you want to
Yeah,
open up the floor?
absolutely. And everybody, thank you so much for these great questions. The first one is from Mark Allen White. Are there unit tests being developed that we can use to quantitatively measure a vendor's tool for adherence to the SysML V2 standard?
Ooh, that's a good question. So we do have conformance from the standard. The standard does define what it means to conform. I'll have to get back to you on that one on the unit test. I don't know if there's any publicly available unit tests. It wouldn't surprise me if there were, but I'm not aware of unit tests to test those. But I do know, again, it's a hot topic. There are repositories. You could just Google, SysML V2 GitHub repositories, specifically from those like Ed Seidowitz that have access to a lot of that kind of detail, and they may have that already for you.
Perfect. And Mark, we'll make sure to follow up even more once we confirm on the unit test portion. Um, and then, awesome. No, thank you. Then Sweet had another question earlier. Is there any directory or convenient way of learning what standard libraries are available and what is available in each library? Essentially, how does one know what to look for, or if they don't know where, like, that it's there? Kind of felt like trying to learn a specific topic by reading the encyclopedia. So,
Yeah.
uh, what's your thoughts on that, Tim?
Yeah, so I mean, if you're in a tool like Cameo, you can, searching can help you find a lot of that stuff. Like for the the unit for Pascal's, if I'm looking in the SI directory, it's going to have the packages built out in a way that is intuitive if you know what you're looking for, or the finds, right? You can still do finds in the tool. If you're outside of Cameo, just trying to figure out what APIs that you have access to, the specification has them. It's dense, but it's there, as well as things like the Cameo documentation. We'll have that as well. Um, we have bits in our training, platform that will dive into those libraries in more detail. It's not necessarily an exhaustive list, but it's covering the things that you would mostly see whenever you're doing your system engineering. So I hope that helps.
All right. And Rupert had a really in-depth question. So here's a fastball for you. Is SysML V2 the inflection point at which MBSE ceases to be an extension of software engineering? Furthermore, he is asking, since a standard published in 2023, IESO-IEC-IEEE. Anyway, there's the standard that he's listing here is the current ISO standard that defines the framework, methods, processes, and tool capabilities for model-based systems and software engineering, often abbreviated from MBSSE or MBSE. Would this shift necessitate or accelerate revisions to this standard? Would this shift also, or probably should, accelerate revisions to ISO IEC 19514 .2017, which standardized SysML V1 as a UML profile. So it's a lot, and you can also see this in the Q&A. But I
Yeah.
think answering the first, is this the inflection point which it ceases to be an extension of software engineering?
To a degree, yes. It is no longer a software engineering solution. It's not built off software engineering. It is going to be intended to be working with other languages to capture the software engineering side. It is truly meant to be systems engineering moving forward. Whether or not, when they, ISO will pick it up as an updated standard, that I couldn't tell you, but yes, it is meant to be divorced from UML, but still functional with software. And other languages will be around to help support that connection, just not
Awesome.
UML.
And Rupert, if there's more that we that you wanted to address, I think that was a thumbs up for me. Perfect. But please let us know. So if there's more, you don't feel like we're getting to the root of your overall question around the standards, happy to take it after everyone else. We'll stick around for a few more minutes too to make sure we're getting everybody's questions answered. Rob asks, can you describe the general collaboration of an MBSE environment with a quote unquote configurator that generates geometry and CAD data? I have a company that uses DriveWorks. Can that be integrated into MBSE?
But that's going to depend on your vendor, and it's part of the specification to describe this and include it, but the specification doesn't go into detail on how it's implemented. So I've only seen what is in the Cameo product, which is using Dassault's CATIA product, which does allow for you to have an integration between the two. While there's geometry here, again, it's more of a placeholder for capturing information with the intention of it being implemented in the future. So not the most satisfying answer, I know, but that's why it's here. And hopefully, this encourages tools to implement them in a seamless way that we can use it a little bit easier.
Awesome. And then one that came in actually over the chat, I don't want to forget the order here. Rob Skihan had a question. Will Simulation Toolkit be able to generate values in the time slices that you had shown earlier?
Yes, yes. So the Sim Toolkit is still being updated for V2. It can handle calculations very well, and it can handle verification. It's still, I want to say that it's the next refresh one, I think, which is in the summertime when they're looking to do more in-depth behavioral modeling. Right now, it's mostly just for calculations and parametrics, but it does a really good job of that. And it does allow you to connect to external parametric or solvers as well. So yes, the intention is for it to be able to handle that. Um, but like I said, some of that stuff is still in development.
Awesome. And Joshua asked, does SysML V2 textual notation provide auto-completion or guidance when scripting a model, such as suggesting valid elements or relationships similar to how Python editors auto-populate possible options?
Yeah, so that's part of the appeal of the textual notation. Again, this is something not prescribed by the specification, the language, but tool vendors, would be the ones to pick up that feature. And Cameo's text notation does exactly that. Um, control space is a common hotkey when you're doing these things, and it's a common one in Cameo, and it can autocomplete for you. And things like code wrapping and auto formatting and uh, edits, block edits and things like that are something that's already built into 2026. You can start playing with it today. Cameo does support that feature. I can't speak for other tools, but Cameo can.
Awesome. And our last question comes from Scotty. Is SysML 2.0 compatible with Cameo versions 22, 24, and I think yes to 26 because it's already in there,
Yeah,
but is it compatible, like reverse compatible, and what are the challenges that they're in?
Yeah, so 2026 is the first official release of V2. So that's where they're intending to use V2 and moving forward. 24, there was a beta for it, and it might have even been refresh 2 or 3, I think, that actually fully incorporated the beta. And you could reach out to Dassault if you're interested in that. I don't know if the program is still around. I'm sure it is. Um, and they will allow you to play with it. It's a setting you have to turn on in your installation directory to get that to work, but it is available as a beta. But realistically, if you're looking to do V2, I would recommend 2026. More specifically, the hotfix one, the newest release that they just did, like a couple weeks ago, and anything moving forward. Because again, a lot of these features are live. They're making updates and adding more things to it constantly. And so if you are looking to do V2, that means you're already interested in doing, cutting edge. Keep up with the tool in this case because it's going to grow really, really fast.
Perfect. All right. That is all of the questions that were put into the chat or the Q&A, I believe. I think we've gotten them all. So Tim, thank you so much. If there's anybody else that has any last questions, please feel free to put into the chat. Um, and we can address those. But if not, we'll wait just a few more seconds. I know we're 2 minutes over. Tim and I will stick around for another minute if anyone has any questions. But everyone, thank you so much for your time. Everyone here at Anola appreciates your attention and engagement. And we have another great webinar coming up next month. We'll be putting that out on LinkedIn. And if you're not signed up for our newsletter, it'll also come through there. So again, look at all the applause. Thank you, Tim. And again,
Thank you so
everyone
much.
for all of the time and attention today. I'll send out a copy to share amongst your peers or to review at your leisure. So again, thanks everyone.
Thank you for your time.
All right. We've got a bunch of thank yous. Again, much appreciated. And we'll send out a copy. Please feel free to hit us up if you have any questions that come afterwards. And thank you again. Have a good
Thank
day,
you.
everyone.